Does God exist? Are science and faith enemies? Your host for this series was an atheist who became a believer in God through his studies in science. Here is public high school teacher John Clayton.
In our first program, we talked about the philosophical underpinnings of the type of approach we're making here. I tried to emphasize the point that I think it's a mistake to view science and faith as adversaries. They don't oppose each other. They support each other. They reinforce each other. And we looked at a discussion that is a logical discussion of how we can know there's a God. There are two choices to start out with. Was there a beginning, or is matter energy eternal? And we've looked at one evidence that, in fact, there was a beginning, the evidence that comes from the expanding universe, the fact that everything in the cosmos is moving away from a central point, and that because that is accelerating, it is not an oscillatory process. If you didn't happen to be with us in the first video, we would really encourage you to go back and look at that before you look at this continuation of that discussion. Let me show you another evidence that we know there was a beginning. This is a picture of the sun. The sun is a remarkable piece of equipment. As a matter of fact, it's interesting as you look at the sun that what you're looking at is something that's very, very different than any process that we see here upon the earth. Down inside the sun, you're not looking at the kind of thing you see in a fire. You know, you hear people talking about the sun burning. And you sort of get the idea that they think somehow that the sun is burning the way a log burns in a fire. And that's not the process at all. You see, what's going on in the sun is very different than that. This is a close-up of the sun. And what you're looking at is a process called granulation. The sun is bubbling, it's frothing from some heat source deep inside. If you saw water sitting on the stove and if it was bubbling, you would know the heat source was down underneath, wouldn't you? And that's very much the same sort of thing that's happening here. We know then the heat source is deep inside the sun. It's also important to understand that we can measure the chemical makeup of the sun. This picture is called a hydrogen alpha picture. What that means is that the light that's coming to the camera is coming from hydrogen atoms in the sun. And doesn't that look different than what you normally think of the sun looking at? You know, the sun normally doesn't look like this. It's showing character here. It's showing a variety of disturbances, which it turns out are pretty much magnetic disturbances. And we can get a ballpark estimate of how much material there is in terms of hydrogen on the sun by this process. We can also do this with helium. And the process that is taking place here is a process that is called thermonuclear fusion. Hydrogen is being squeezed together to produce heavier elements. The primary process that we're familiar with on the sun is helium. So in our animation here, you see two hydrogen atoms being pushed together, being slammed together to produce helium. The problem is that the helium has less available energy than the hydrogen does. So the result is that energy has to be released. So the flash that you see is the power that drives the sun. In recent years, scientists have been successful in measuring the amount of hydrogen on the sun, the amount of helium on the sun, and making predictions about what the sun has been doing and how long it's been doing it and what the processes are on the sun. It's absolutely incredible. I mean, we're talking numbers like 290 million tons of hydrogen every second being consumed on the sun and being turned into heavier elements, helium particularly. Now, this just isn't the sun. Every star in the sky generates energy by the same process. When we look out into space and we see exploding galaxies, hydrogen is still the basic source. Hydrogen is the universal fuel of the cosmos. Now, there's a very simple principle here that shows that there was a beginning. You have a car, and you put gasoline in the car. If you don't put gasoline in the car and you drive the car, what happens? Well, that doesn't take any imagination. You run out of gas. You have to put fuel in the vehicle to enable the vehicle to operate. We all understand that. Well, I had some daughters that didn't seem to understand that, but most of us understand that you got to put fuel, you got to put gas in the car to make it go. Now, this just isn't the car. It's also true of the cosmos. If every galaxy, every star, every process in nature is dependent upon hydrogen. If hydrogen is being consumed everywhere in the cosmos, and if that has been going on forever and ever and ever, how much hydrogen would be left? It's like asking, if you drive the car on a very long trip and you don't put any gas in the car, how much will be left? And the answer is obvious. The gas gauge would be on empty. We know from a scientific standpoint that there is no way to generate hydrogen, that the processes in the cosmos tend to moving things apart and so forth do not re-add hydrogen to the process. And especially since the universe is expanding and accelerating in its expansion, it is very clear that you can't add any fuel to the process. So how much hydrogen should there be left in the cosmos? And the answer, of course, is none. Like the car that has been driven many, many miles, the universe would be completely void of hydrogen. There would be no hydrogen left. It would have all been burned up. But the fact is, the sun, and get this, the sun has only burned 2% of its original fuel, according to our calculation. The sun still has 98% of the hydrogen it had the day it came into existence. And that's true of all stars in space. We look out into space with our powerful telescopes, and we see things like this picture, an area of space full of glowing clouds of hydrogen. We take telescopes called radio telescopes that measure wavelengths, that tell what element they came from. And there's a spectral line called the hydrogen 21 centimeter line, and that line shows up everywhere in the cosmos. The cosmos is full of hydrogen, and that could not be unless there was a beginning. So not only does the expanding universe show us that there was a beginning, but the fuel system of the cosmos shows us there was a beginning. And there's one more evidence I'd like to show you. What you're looking at on the screen right now is a very, very famous law. It's called the second law of thermodynamics. And what it says is, as you can see, that any closed system. Now, what is a closed system? A closed system is a system in which no energy is added to the system. The Earth is not a closed system. So you can't use the second law of thermodynamics on the Earth because the Earth is having energy added from the sun as well as other sources. But in any closed system, things tend to move towards a condition of disorder. Carl Sagan used to say, the cosmos is everything that is or was or ever will be. Now, whether you agree with the statement or not, and I don't, I think there are some problems with the statement, but if you accept that as a view of the cosmos in any way, shape, or form, it's a gorgeous definition of a closed system. So what's this got to do with anything? All right, let me give you a really simplified explanation of the second law. Many years ago, we had a daughter named Wendy. And when Wendy became a part of our family, she was moved into a room. And the room looked something like what you see on the screen. It was perfectly organized. Everything had a place. It was beautiful. What happened to that room? Well, it looked more like this by the time she left it. And as a matter of fact, if there hadn't been an external source of energy, her parents, the room would have been in total chaos. This is the second law. Now that's a very, very trivial example, but it gives you a perspective of this principle behind the law. And it's important to understand that this applies in the cosmos. It applies to our lives. I am getting more and more disordered with time. We call that aging. And eventually, I will become disordered enough that there will be death. This isn't just human bodies. The cosmos is aging. We talk about heat death related to stars. And the whole idea then is that the universe is continually running down. We live in a system that is becoming more and more disordered. Now think with me for a minute. If the cosmos has always been, if there was